At 4 hours on a Sunday in the late spring, the mountain range that separates the high plateau from its northwestern corridor was already swallowing light. Not consuming it dramatically, the way fire does, but absorbing it the way old concrete absorbs rain, slowly, completely, without residue. The thermal signature of the ridgeline, captured on satellite arrays passing overhead at that hour, showed a temperature inversion sitting at approximately 2,400 meters of elevation. Cold air, denser than the valley floor beneath it, had settled into the passes like sediment. The fog that formed inside it was not the thin morning mist that disperses by 0700. It was orographic fog, the kind produced when saturated air is forced upward by terrain, cooled below its dew point, and held in place by a pressure system that had no interest in moving. It was, in the vocabulary of rotary aviation meteorology, a category of atmospheric condition that flight planners call a hard ceiling, not a soft advisory. A hard ceiling. The distinction matters in the forensic reconstruction of what came next because the question is not whether the ceiling was visible on the instrumentation available to the command that ordered the flight. The question is whether anyone in that command structure had the institutional authority or the institutional habit to say, stop. That question is the audit. The aircraft involved was a Bell 212 twin-turbine helicopter, a platform that first entered service in 1969. That number should be held in the mind for a moment, not as trivia, but as a data point in the industrial calculus of the event. 1969. The integrated circuit was 6 years old. The first moon landing had not yet occurred. The concept of fly-by-wire avionics was theoretical. The Bell 212 was an engineering achievement of its era, a reliable, twin-bladed, semi-rigid rotor system driven by a Pratt & Whitney Canada PT6T3 coupled turbine, capable of carrying 14 passengers at a service ceiling of approximately 4,877 meters. It was built for utility. It was built to move people across distances that fixed-wing aircraft could not service. It was not built for the sensor suite, the redundant navigation architecture, or the terrain avoidance systems that the mountain corridor it entered on that Sunday morning demanded. The high plateau, across decades of procurement cycles and military investment, had developed an inventory of modern rotary assets. It possessed platforms with forward-looking infrared, with GPS-integrated autopilot, with synthetic aperture radar capable of constructing a real-time three-dimensional map of the terrain envelope through which the aircraft was flying. Those assets existed within the command's logistical reach. They were not deployed on this mission. The Bell 212, a machine that predated the microprocessor, carried the most critical human cargo the plateau's political structure had produced in a generation. That gap between the capability that existed and the capability that was used is not a minor operational footnote. It is the systemic failure from which every other element of the event proceeds. It is the first line of the audit. To understand why a command makes that choice, aging platform, maximum value personnel, high-risk atmospheric corridor, you have to understand the organizational psychology of procurement signaling. The high plateau's military doctrine in the decades preceding this event had been constructed around a specific projection of invulnerability. Its communications infrastructure, its ballistic missile program, its proxy force architecture across the regional theater, all of it was designed and narrated as evidence of a hardened, modern, and self-sufficient military command. The gap between that projection and the Bell 212 sitting on the mountainside represents something that strategic analysts call a logistical choke point. A place where the resources available inside the system cannot keep pace with the image the system has constructed of itself externally. The aging rotary fleet was not a secret. Maintenance records, when cross-referenced with open-source flight logs and the service histories of export platforms, told a consistent story of a command that had invested its procurement capital in kinetic strike systems, missiles, drones, electronic warfare arrays, and had allowed its transport aviation to calcify in place. This is not unusual. It follows a pattern observable in multiple regional commands across the contemporary threat landscape. A command under sustained sanctions pressure, its hard currency reserves compressed, its access to Western aerospace components severed, will make triage decisions in its procurement architecture. It will prioritize the systems that project deterrence outward. The IRBM on the launch pad is a signal to adversaries. The aging helicopter in the mountainside hangar is invisible until it isn't. The rotor system of the Bell 212 operates on a semi-rigid, two-blade, teetering design. Unlike fully articulated rotor systems on more modern platforms, the teetering design limits the aircraft's ability to maneuver aggressively in confined airspace. In the orographic fog of the mountain corridor, where spatial disorientation happens within seconds of visual reference loss, the margin between controlled flight and kinetic impact with terrain narrows to a geometry that the pilot's vestibular system cannot resolve without instrumentation. The inner ear, under spatial disorientation, will report a false horizon. The body will insist it is level when it is in a graveyard spiral. The only counter to that insistence is an instrument scan, a disciplined, trained, mechanical transfer of trust from biological sensation to the altimeter, the attitude indicator, the vertical speed indicator. That transfer requires that those instruments be calibrated, functioning, and critically, that the pilot have logged sufficient instrument flight time to execute the scan under the cognitive compression of a degraded visual environment. The atmospheric record for the corridor on that morning showed visibility below 100 meters at the accident elevation. The orographic fog had not thinned. The pressure system held. What the aircraft entered when it descended into that pass was not a weather advisory, it was a gray static wall, a thermal and optical environment in which the visual cues that VFR flight depends upon had been replaced by uniform, featureless white. No horizon, no terrain reference, no separation between the sky above and the ridgeline below. Only the instruments remained. And in the Bell 212, the instrument suite was what 1969 had provided: functional, analog, and entirely dependent on the pilot's ability to prioritize it over every instinct that evolution had built into the human body for spatial navigation. The terrain in that corridor rises without consistent warning. The ridgelines are not gradual, they are abrupt, geological formations that have the vertical profile of walls rather than slopes. A radar altimeter, which measures height above terrain rather than height above sea level, would have provided a continuous audio and visual warning as the aircraft descended toward the surface. The Bell 212 in the configuration documented for this mission did not have a functioning terrain avoidance warning system recorded in the operational data. What it had was the pilot's training, the pilot's instrument currency, and the pilot's ability to maintain controlled flight inside a gray static envelope that offered the vestibular system nothing to hold on to. At some point in the descent, the aircraft's rotor disc intersected the terrain. The forensic signature of that intersection, the pattern of impact, the distribution of the wreckage field, the metallurgical evidence on the rotor blade remnants, tells the story of what the physics required, not what anyone intended, what the physics required. That distinction is the beginning of the audit. In the 40 minutes before the signal dropped, 3 separate communications relays were tracking the aircraft's transponder signature. The first was a military communications node positioned on the plateau's northwestern infrastructure grid, a ground-based receiver operating in the VHF band, logging position data at intervals consistent with standard rotary flight monitoring. The second was a commercial aviation relay, a passive receiver that had no operational relationship with the mission but was doing what commercial receivers do at all hours, logging everything that broadcast in its frequency range. The third was overhead, a signals intelligence platform in low Earth orbit, operated by a command architecture whose name is not relevant to this audit, but whose presence over that corridor on that morning is a matter of orbital mechanics, not coincidence. At the altitude and inclination of its pass, it would have had a thermal acquisition window of approximately 11 minutes over the accident zone. What that platform recorded and what conclusions its analysts drew from the thermal and signals data remains in the gray zone of information that moves between commands without ever entering the public forensic record. That gap between what was recorded and what is acknowledged is itself a data point. It tells you something about the nature of the silence that followed. The silence is worth auditing on its own terms. When the transponder signal ceased, the ground relay logged the dropout as a technical anomaly first. In rotary aviation, brief transponder dropouts in mountainous terrain are not statistically unusual. The terrain itself masks the signal. The ridge geometry creates shadow zones where the line of sight between the aircraft's transponder and the ground receiver is interrupted by the physical mass of the mountain. The operators at the ground relay waited. The standard protocol in most command structures is a defined window, typically between 3 and 8 minutes, before a dropout is escalated from a technical anomaly to a potential distress event. What happened inside that window, in the command structure responsible for the flight, is the organizational layer of the audit.
The High Plateau's command, in the organizational culture documented through its operational history, had a strong institutional bias toward the first error, toward patience, toward not generating alarm prematurely, particularly for missions involving the highest levels of the political structure. The reasons for that bias are not mysterious. In a command environment where political authority sits above military judgment in the decision hierarchy, generating a false alarm about the safety of a senior figure carries institutional consequences that generating a false negative does not, at least not immediately. The operator who waits too long loses his principle. The operator who raises alarm prematurely loses his position. That asymmetry shapes behavior across time. It becomes embedded in the institutional reflex. And on that Sunday morning, in the 40 minutes between the last confirmed transponder ping and the formal initiation of a search response, that reflex was operating exactly as it had been conditioned to operate. This is the systemic failure in its purest form, not a mechanical breakdown, not a weather anomaly that no forecaster could have predicted. A cascade of institutional decisions, each one individually defensible within its local logic, that collectively produced an outcome no individual in the chain intended. The meteorologist who filed the weather report did not order the flight. The procurement officer who approved the maintenance budget did not set the departure time. The operations planner who selected the routing did not sit in the cockpit. The political authority whose schedule drove the mission timeline did not assess the airworthiness of the platform. Each node in the chain performed its function within its defined parameters. The chain as a whole failed. This is what engineers, when they are being precise, call a normal accident, a term that sounds like a contradiction, but is in fact a forensic category. It describes an accident that was not caused by a single catastrophic error, but by the routine interaction of multiple systems, each operating within its normal range, producing an outcome that the system as a whole could not prevent. The Bell 212's maintenance record, reconstructed from the operational documentation available in the post-incident forensic period, reflects the procurement calculus described in the first segment of this audit. The platform had accumulated flight hours consistent with a heavily utilized transport asset. In Western aerospace maintenance doctrine, a rotary platform accumulates mandatory inspection thresholds at defined intervals, not just calendar time, but airframe cycles, rotor head cycles, gearbox hours. Each threshold triggers a maintenance event that is logged, certified, and traceable. The certification chain creates accountability. It also creates a paper record that survives the aircraft itself, which is why accident investigators can reconstruct maintenance histories from documents rather than wreckage. The High Plateau's maintenance documentation for its transport aviation fleet, particularly for the older Western origin platforms acquired before the sanctions architecture closed the supply chain, operated in a different environment. Spare parts sourced through gray market procurement channels do not carry OEM certification paperwork. Maintenance performed by technicians trained on systems that predate the current technical manual ecosystem does not always generate the granular cycle-level logging that accident forensics depend on. The result is not necessarily an unsafe aircraft. It is an aircraft whose safety margin is less legible, less auditable than the documentation suggests. The rotor head of the Bell 212, specifically the trunnion assembly and the pitch change mechanism, are components that accumulate stress in ways that visual inspection alone cannot fully assess. Metal fatigue operates below the surface. It operates at the grain boundary level of the alloy, in the microscopic crystalline structure of the steel, where repeated stress cycles initiate cracks that are invisible to the eye until they are not. Non-destructive testing, ultrasonic inspection, eddy current analysis, dye-penetrant examination can detect these cracks before they propagate to failure. These methods require equipment, trained technicians, and a maintenance culture that prioritizes them over the simpler metric of hours since last visual inspection. Whether those methods were applied to the specific components of the specific aircraft on its last maintenance cycle before that Sunday morning is a question the forensic record does not fully resolve. What the forensic record does resolve is the outcome. The aircraft did not return from the mountain. The mountain did not move. The electronic math of the search response that followed is its own chapter in the audit. The initial search assets deployed into the corridor were themselves constrained by the same atmospheric conditions that had consumed the original flight. Search and rescue rotary platforms attempting to operate in aerographic fog below minimums are not conducting a search, they're conducting a risk transfer, moving the probability of a second accident from 0 towards something measurable in exchange for the possibility of finding the first aircraft while a survivor window still existed. The thermal imaging systems on the search platforms, where those platforms had them, were degraded by the same temperature inversion that had produced the fog. The inversion creates a thermal layering effect in which the background temperature of the terrain approaches the temperature of a human body closely enough that the contrast signature a FLIR system depends upon is compressed to near noise levels. In an environment where the terrain background reads at 12 to 15 degrees Celsius and a living body reads at 36, the contrast is workable. In a temperature inversion where the terrain surface at altitude reads at 30 to 33 degrees from absorbed solar loading trapped beneath the inversion layer, the signal is lost in the static. The search platforms were looking for a thermal signature in an environment that had turned the thermal landscape into a uniform gray field. The mathematics of that search were not favorable from the first hour. When the wreckage was finally located, it was not located by the thermal imaging of a search aircraft. It was located by a ground team operating on foot in the terrain, guided by a signal from a locator beacon that had survived the impact. The beacon, a legacy ELT system, an emergency locator transmitter operating in the 121.5 MHz international distress frequency, had been transmitting since the moment of impact. The irony embedded in that data point is not subtle. The most modern search technology available to the command, the infrared arrays, the signals intelligence overhead pass, the coordinated rotary search effort, had not resolved the location. A 40-year-old radio, broadcasting on a frequency that the international aviation community had largely deprecated in favor of digital 406 MHz systems, had done what the sophisticated systems could not. The beacon spoke. The ground team listened. The mountain gave up its location in the only language it had been given the tools to speak. In the third week after the mountain gave up its location, the silence that had initially read as grief began to read as something more structurally significant. Grief, in the vocabulary of political communication, has a defined arc. It peaks, it is performed, it is institutionalized into memorial language, and then the machinery of the state moves through it and past it. What the High Plateau's command structure produced in the weeks following the event did not follow that arc cleanly. The silence was too long in certain registers and too loud in others. The internal communications that leaked, not through espionage but through the ordinary porousness of institutions under stress, suggested a command that was not grieving so much as it was conducting its own internal audit, figuring out what it now was, mapping the delta between the architecture of authority that had existed before the Sunday morning in the mountains and the architecture of authority that remained after it. That mapping process, conducted under the pressure of external adversaries who were doing their own version of the same calculation, is what strategic analysts call a force multiplier moment in reverse, a point where the subtraction of a single node from a command network produces a multiplication of uncertainty that exceeds what the subtraction of that node's individual contribution would logically generate.
The principal who had been lost was not simply an administrator. The high plateau's political structure, across decades of institutional evolution, had developed a specific model of authority concentration. Not unique to this command, versions of it are visible in multiple regional hegemonies across the contemporary threat landscape, but executed here with a particular intensity. The model works by making the senior figure the irreplaceable interpreter of the system's core logic, the ideology, the foreign policy doctrine, the relationship between the military command and the political structure, the negotiating posture toward external adversaries. All of it ran through a single interpretive intelligence that had spent decades constructing the internal grammar of the state's self-understanding. The adversaries who surrounded the high plateau understood this before the plateau's own internal command had finished processing it. The signal intelligence community, multiple overlapping national architectures whose collection assets had been saturating the plateau's communications environment for years, detected the change in communication patterns within 72 hours of the event. Not content, patterns. The frequency of certain encrypted traffic, the activation of backup communication protocols that had previously been dormant, the geographic redistribution of command personnel between facilities that had previously been lightly staffed. These are not the patterns of a system continuing normally. These are the patterns of a system that has detected its own vulnerability and is attempting to redistribute its exposure before an adversary can target the concentration. In the electronic math of modern signals intelligence, pattern metadata is often more revealing than content. A command that suddenly begins encrypting communications that it previously transmitted in the clear is telling you something. A command that suddenly begins encrypting communications that were already encrypted, adding a second layer, is telling you something louder. The plateau's communications environment in the weeks following the mountain event told the surrounding signals architecture something very loud. The gray zone escalation that followed was not a single event. It was a texture, a change in the density and frequency of sub-threshold provocations across the regional theater. The proxy force architectures the plateau had constructed across its adjacent operational zones did not stand down in the aftermath of the event. They accelerated, fractionally, in ways that were individually deniable but collectively legible as a signal. The signal was not aggression. It was a proof of life transmission. It was the command structure of the plateau broadcasting to every adversary and every allied proxy simultaneously. The system persists. The kinetic architecture remains functional. Do not mistake the silence for vacancy. This is a common behavior in commands that have suffered a sudden leadership disruption, the immediate over-signaling of capability to compensate for the uncertainty that has been generated. It is, in strategic terms, the equivalent of a wounded organism making itself appear larger. It deters the immediate opportunistic strike. It also reveals the wound by the very fact of the compensation. The overseas superpower, watching from its remove across the deep water, ran its own calculus on the event with the dispassion that geographic distance permits. Its analytical community produced assessments that it did not share publicly, but that were legible in the adjustment of its regional posture in the weeks that followed. Naval assets that had been maintaining a routine patrol cadence in the adjacent maritime zone shifted their operating pattern. The shift was small, measurable in nautical miles of standoff distance, in the frequency of electronic emissions, in the tempo of reconnaissance overflights that the plateau's air defense network logged but could not intercept. Small shifts in the posture of a superpower are not small signals. They are the most precise language that large military architectures speak. Every regional command that was watching, and all of them were watching, translated the shift correctly. The overseas superpower had concluded that the plateau's command environment was temporarily degraded. It was not going to exploit that degradation kinetically, but it was going to ensure that every system it maintained in the theater was positioned to exploit it if the calculus changed. The island chain command, whose relationship with the high plateau had been conducted across decades of ambiguity, neither alliance nor open hostility, but a permanent negotiation conducted in the gray space between, made its own adjustment. The adjustment was economic rather than military in its primary vector. A series of trade facilitation agreements that had been moving through the bureaucratic pipeline of both commands for several months were quietly decelerated. not canceled, decelerated. The distinction is important. Cancellation is a signal. Deceleration is a question, a way of saying we are waiting to see who you become before we finish becoming your partner. It is the language of strategic patience deployed as a diagnostic tool. The island chain command was not abandoning the plateau. It was pausing to assess whether the plateau that emerged from the mountain event would be the same interlocutor it had been developing its relationship with, or something different, something that would require a recalibrated posture. What emerged across the months that followed was a plateau that was recognizably continuous with what it had been, but operating with a different internal rhythm. The decisions that had previously moved through a single interpretive center now moved through a more distributed architecture, faster in some registers, slower in others, and occasionally inconsistent in ways that the previous structure had not been. The inconsistency was not dramatic. It was the kind of subtle drift that only becomes visible when you map the decision pattern over time and compare it to the baseline. Analysts who did that mapping found what they expected to find, a system that was adapting, but adapting reactively, filling the interpretive vacuum with committee consensus rather than singular vision. Committee consensus produces a specific kind of foreign policy. It produces policy that is robust to internal challenge because every faction has signed on to it, but brittle in execution because no single intelligence is accountable for its coherence under pressure. In the gray zone environment, where adversaries are specifically probing for incoherence, that brittleness is a vulnerability with a measurable risk profile. The Bell 212 on the mountainside was not a weapon. No adversary put it there. The fog was not manufactured. The pressure system that held the temperature inversion in place over that corridor on that Sunday morning was indifferent to the significance of its passengers. The forensic reconstruction of the event does not require an external actor to account for the outcome. The outcome was produced by the internal logic of a system that had spent decades investing its resources in the projection of external strength while allowing the infrastructure of its own institutional continuity to calcify in the shadow of that projection. The gap between the missile on the launch pad and the aging helicopter in the mountain fog is not a gap that an adversary created. It is a gap the system created for itself, over time, through the accumulation of procurement decisions, maintenance cultures, organizational hierarchies, and risk assessment frameworks that each made local sense and collectively produced a systemic exposure that the mountain was simply the first external force to find. This is the nature of the silent war that the contemporary threat landscape is conducting across every domain simultaneously. It is not always kinetic. It is not always electronic. Sometimes it is atmospheric. Sometimes it is metallurgical. Sometimes it is the simple, cold arithmetic of a rotor blade cycling through stress in a maintenance environment that cannot see the cracks forming at the grain boundary level, cannot see them until the mountain makes them visible in the only way mountains know how. Catastrophically, finally, without appeal. The audit of the high plateau does not end on that ridgeline. It begins there. Because what the mountain revealed about the gap between projection and reality, between the hardened exterior and the aging interior, is not a lesson that is unique to one command in one corridor on one Sunday morning in the late spring. It is the structural condition of the current era. Every command that has prioritized the outward signal over the inward infrastructure carries some version of that gap. Every aging platform in every transport fleet that operates beneath the glamour line of the procurement budget represents the same industrial math, the same calculation, the same bet that the gap will not be found before the command is ready for it to be found. The mountain does not negotiate. The fog does not defer. The physics of rotor metal under stress does not care about the political significance of its cargo. It only knows cycles. And eventually, given enough cycles, every crack that was invisible becomes the only thing visible. That is the audit. That is the silence. That is the calculus of the era we are in, where the most consequential failures are not the ones that adversaries engineer, but the ones that systems engineer for themselves, slowly, invisibly, in the gray static between the strength they project and the infrastructure they have actually built. The static does not lie. It only waits.